Hello friends, I am Shivaji Sonono. Welcome to the class of physics. In this video, we will see some multiple choice questions on thermodynamics. So what is meant by thermodynamics? Thermo means heat and dynamics means conduction. So thermodynamics means the conduction of heat from one place to another place, or from one part of the body to the another part of the body. Thermodynamics takes place by three different processes. First one, conduction. Second one, convection. And third one is the radiation. So we'll see some MCQ questions on this thermodynamics. So first question from the booklet. In the adiabatic expansion of the gas, four options are given. What is the effect on temperature, pressure, as well as thermal energy? So first one, you know that the adiabatic process means the exchange of heat, change in heat is equal to zero. Means when heat exchange, heat of flow is equal to zero, amount of work done in the adiabatic process, in the adiabatic expansion is equal to zero. Means it implies that the total heat supplied is equal to total internal energy. And due to this, the temperature of this system is get decreases. So correct option for the option number one. This is the theoretical question. That is the temperature of the in the adiabatic expansion is get decreases. The correct option is option number C. Next one, question number two. In question number two, a monoatomic ideal gas initially at the temperature T1 is enclosed in a cylinder fit with the frictionless piston. The gas is allowed to expand adiabatically to the temperature T2 by releasing the piston suddenly. If L1 and L2 are the length of gas column before and after expansion respectively, then the ratio of temperature T1 by T2 is. So initially the monoatomic gas is there with the temperature T1 and its length of the gas column is L1. Then the temperature getting increases T2, then the length of the gas column is L2. Then find out the ratio of temperature. According to the equation of state, we know that in the adiabatic expansion, change in heat is equal to 0. So dq is equal to 0. So you can write down this equation according to the first law of thermodynamics. dq is equal to du plus dw, and it is equal to 0. So you just simplify it, we get this gamma dv by v plus a dp by p is equal to 0. So p raised to gamma is equal to constant. And we are interested in the relation between temperature and the volume. So in the adiabatic process, the temperature and volume raised to power gamma minus 1 is equal to constant. Simplify it, write down the ratio of temperature with respect to the length, because length is directly proportional to the volume. So we just write down the length L2 upon L1, inversely proportional. So gamma is equal to, for the monoatomic gas, gamma is equal to 5 by 3. So it is 2 by 3. So we get T1 by T2 is equal to L2 upon L1, and its power is 2 by 3. So correct option for the question number 2 is option number D. Next one, question number 4. In question number 4, 5 mole of hydrogen gas is heat from 30 degree to the 60 degree Celsius at constant pressure. At constant pressure means this is isobaric process. Heat given to the gas is, only change in temperature is given, and 5 mole of hydrogen gas is given. Change in temperature from 30 to 60 means change in temperature is 30 degrees Celsius, and this is N is equal to 5. Then for the diatomic gas, hydrogen, this is the diatomic gas. So for this case, this Cp is equal to 7 by 2 R. So heat absorbed dq is equal to, for the isobaric means this P is equal to 0. So we get dq is equal to ncp into delta T, heat absorbed. Put the value of n 5, Cp is equal to 7 by 2, so it is 3.5 into 2 into 30, delta T is equal to 30. When you simplify it, we get change in heat is equal to 150 Kelvin. So correct option for the question number 4 is option number C. The value of R is given. This is the given case. Correct option is option number C. Question number 5. When an ideal gas, its gamma is given 5 by 3, heat under the constant pressure, what percent of given heat energy will utilize in doing external work? So according to the first law of thermodynamics, dq is equal to, simplify it. So write down this equation in terms of change in heat as well as in terms of change in internal energy and its ratio. So its ratio is nothing but 1 by gamma. So what is the gamma? Gamma is equal to 5 by 3 for this gas. So it is 3 by 5. So gamma is equal to 5 by 3. Simplify it. So dw by dq is equal to 1 minus du upon dq. Du upon dq is 3 by 5. So simplify it, it is 2 by 5. Then finally we get 2 by 5 and its percentage. So it is 40%. Means we can conclude that in question number 5, the amount of heat energy utilized for the amount of work done is 40% of its given energy. So correct option for question number 5 is option number A. 40% of heat absorbed is used in doing external work. Next one, question number 6. In question number 6, Carnot engine takes 103 kilocalorie of heat from the reservoir at 627 degrees Celsius and exhaust it to the sink at 27 degrees Celsius. The efficiency of the engine is. So efficiency of Carnot engine is equal to 1 minus T2 upon T1. The temperature of sink is 27, so it is 300 Kelvin. And temperature of the reservoir or the source 627, so it is 900 Kelvin. So put the value 300, 900, it is 2 by 3. Percentage of 2 by 3, it is equal to 66.6%. So for the question number 6, correct option is option number D. Next one, question number 7. 1 kilogram of diatomic gas is at the pressure of 8 into 10 raised to power 4 Newton per meter square. The density of the gas is given 4 kg per meter cube. What is the energy of the gas due to its thermal motion? So to calculate the energy, we know that this energy is equal to, it is 5 by 2 PV. So calculate the volume first one from mass and density. Mass is 1 kilogram. Density is 4, so volume is equal to 1 by 4. So for the diatomic gas, the amount of kinetic energy is the degree of freedom by 2 into PV. So 5 by 2 into PV. P is already given 8 into 10 raised to power 4 and volume is calculated 1 by 4. Simplify it, we get the answer 5 into 10 raised to power 4 Joule. So correct option for the question number 7 is option number B. Next one, question number 8. A diatomic ideal gas is used in a Carnot engine as a working substance. If during the adiabatic expansion part of the cycle, volume of the gas increases from B to 3B, 32B, the efficiency of the engine is. So there is a change in volume, then calculate the efficiency of engine. So for the adiabatic expansion, relation between temperature and volume. So T1 by T2 is equal to, this is V2 upon V1. So V1 get cancelled, we get 32. And its power gamma minus 1. Gamma for this is 5 by 2. It is 7 by 5 for the diatomic gas. So put the value of gamma here. Simplify it. So gamma minus 1 it is 2 by 5. So 32, 2 by 5 and T2. So find out T1. T1 is equal to 4 of T2 because the power of 2 by 3 of 32 is 4. So now efficiency of the engine it is equal to 1 minus T2 upon T1. Put the value of T1 is 4 T2. Simplify it, T2 get cancelled, so 1 by 4, so 3 by 4. Percentage of 3 by 4 in it is 0.75. So efficiency is equal to 0.75. The correct option for the question number 8 is option number D. Question number 9. Carnot engine operating between T1 and T2 efficiency is 1 by 6. When T2 is lowered by 62, its efficiency increased to 1 by 6. Then T1 and T2 are. So two conditions are given. In the first case, efficiency is 1 by 6 when temperature is T1 and T2. Then when T2 is decreased by 62, then efficiency is 1 by 3. So we get the two cases. 1 by 6 is equal to equation number 1 and 1 by 3 is equal to equation number 2. So simplify these two equations, we get the temperature of the source and temperature of the sink. Source is 372 Kelvin and the sink is 310 Kelvin. So for this question number 9, the correct option is it is 372 Kelvin, 310 is option number E. Question number 10. The ratio of work done by an ideal diatomic gas to the heat supplied by the gas in isobaric process. Isobaric means at constant pressure. So according to the first law of thermodynamics, work done is equal to dq minus du. So put the value of dq mcp into delta T and du is equal to mcv into delta T at constant pressure and at constant value. Put the value of this cp 7 by 2 r and cv 5 by 2 r for the diatomic gas. This is the standard one. So W is equal to Nr into delta T. So heat supplied. So we get it is equal to 7 by 2 R into delta T. So question number 1 and question number 2. Just find out the ratio of these two equations. W upon Q. We get 2 by 7. So correct option for question number 10 is option number C. Next one. Question number 11. For a gas, R upon Cv is equal to 0.67. This is the given case. This gas is made up of molecules which are. So by using this condition, just find out the value of gamma. When you get the value of gamma, we can identify the type of the molecule. Comparing with the standard equation, Cv is equal to R upon gamma minus 1. So R upon this you can write down. It is R upon Cv, it is nothing but gamma minus 1. So gamma minus 1 is given 0.67. So gamma is equal to 1.67. So when you get the value of gamma, this is so according to the value of gamma, we can conclude that the gas is monoatomic. Gas is monoatomic. So next one, correct option is B. So next question, question number 12. In question number 12, R is the universal gas constant. Amount of heat need to rise the temperature of 2 mole of ideal monoatomic gas from 273 to 373 Kelvin when the gas is. So two conditions are given. So monoatomic gas is given of 2 mole and its temperature has to be increased from 273 to 373. And calculate the required heat. So we can calculate this is temperature change 373 minus 273, so it is 100. So this is the isochoric process. dV is equal to 0. So W is equal to 0. So we can write down Q is equal to dU. So what is dU? It is mCV into delta T. So NCV into delta T. Write down the value of CV. It is 3 by 2 R. So 2 get cancelled, 3 into 100 into R. So it is 300 and R. So correct option for question number 12 is option number C. Question number 13. In a thermodynamic process, pressure of fixed mass of the gas, heat 20 joule and 8 joule of work is done on the gas. If initial internal energy of gas is 30 joule, what will be the final internal energy? So dq is given, it is 20 joule heat of the gas. Amount of work done is 8 joule, so it is negative. So initial internal energy is 30 joule. According to the first law of thermodynamics, so dq minus dw, so minus 20 plus 8, so it is minus 12 joule. So change in internal energy, du is equal to u2 minus u1. But u1 is given 30 joule, so u2 is equal to du plus u1. So 30 minus 12, so it is 18 joule. So for the question number 13, the correct option is option number D. Question number 14. An ideal heat engine working between temperature TH and TL. Means TH means higher temperature and TL means lower temperature. Has efficiency eta. If both the temperature are rise by 100 Kelvin each, new efficiency of the heat engine will be. So when temperature lower and higher temperature increase by 100 degree Kelvin, then what is the effect on efficiency? This is the initial condition. At temperature TH and TL, second one get increased by 100 Kelvin both the temperature, then what is the efficiency? So for the first case efficiency is eta, second case efficiency is equal to eta dash. Just add 100 in both the cases. Simplify it, we get eta dash is equal to, it is TL minus TH means low temperature minus higher temperature upon low temperature plus 100. So divided by 100 means it implies that this temperature is less, eta dash is less as compared to the eta. So new efficiency is less than the initial efficiency. So what is the correct option? Option number C, less than eta. Eta dash is less than initial efficiency. So correct option is option number C. Next one, question number 15. In question number 15, a Carnot engine operates between 327 and 27 degree Kelvin. How much heat does it take from 327 degrees Celsius reservoir for every 100 joule of work done? So T1 and T2 is given, it is 600 Kelvin and T2 is 300 Kelvin. We just convert this 27 degrees Celsius to Kelvin and 327 degrees Celsius into the Kelvin. Then amount of work done W is equal to Q1 minus Q2. So efficiency is equal to, we just write down it is W upon Q and it is equal to T1 minus T2 upon T1. So Q is equal to T1 upon T1 minus T2 into W. Just simplify this equation. So put the value of T1 600, again 600 minus 300 into amount of work done, it is 100 joule. So simplify it, we get 200 joule. So it implies that the amount of heat take from the reservoir for every 100 joule of work done is 200 joule. So correct option for question number 15 is B. Question number 16. Latent heat of vaporization of the water is 2240 joule per gram. If the work done in the process of vaporization of 1 gram is 168 joule, then increase in internal energy. So amount of heat is given and this heat is 2240 joule per gram. Then amount of work done is also given, it is 168 joule. Then amount of increasing internal energy. Straightforward question. du is equal to du minus dw. So put the value, we get 2072 joule of internal energy get increases. So correct option for question number 16 which is option number C. Next one, question number 17. Internal energy of N1 mole of hydrogen of temperature T is equal to the internal energy of N2 mole of helium at temperature twice. So two gases are given, that is hydrogen gas at temperature T1 and mole N1. Second one, that is the helium gas at temperature twice T and mole is N2. So molar heat capacity for the hydrogen and for the helium. Hydrogen is the diatomic gas and helium is the monoatomic. So for the diatomic 5 by 2 R, for the monoatomic 3 by 2 R, and its internal energy. So write down the equation for hydrogen, write down the equation for helium. So it is N1 Cv for hydrogen into T, N2 Cv for helium into T. So put the value of Cv for diatomic and monoatomic, and its internal energy condition is equal. So compare this, we get ratio of the mole of the gas N1 by N2 is equal to 6 by 5. The correct option for question number 17 is option number C. Next one, question number 18. Very interesting question. A fixed mass of the gas is automatically expand to double of its volume. Automatically expand to double of its volume from V1 to twice V. And then isochorically heat. Isochorically means volume is remains constant. So A to B and then B to C. Heat to bring the gas to its original pressure. The ratio of final to initial temperature. The ratio of final to initial temperature will be final to initial temperature. So you can write down the temperature for the first case and the second case. When this is get changes from, it is automatically and then isochorically. So in this case T1, you can write down the initial case. T1 is equal to PV upon NR according to the ideal gas equation. Second case T2 is equal to P twice V because volume get increased double upon NR. So only volume get changes V2 twice V. So ratio of temperature T2 upon T1 is equal to 2:1. So correct option for question number 18 is option number D, that is from ratio of temperature is 2:1. Similarly, in this question we can calculate the work done in two steps from ABC to AC. This is the one extra part to calculate the ratio of work done in isochoric process and isothermal process. So this is the work done for ABC path and the work done for AC. AC means isothermal process. This is AB to BC and then from C to A or A to C. Isothermal, this is isobaric and isochoric process. So we can calculate the work done for ABC and AC and its ratio. So we get the ratio of work done is equal to L of. So remember this part, this is the one additional part. Next one, question number 19. In question number 19, a A monoatomic gas is supplied heat Q very slowly, keeping the pressure constant. The work done by the gas is pressure is constant, so du in terms of the Cv and dq in terms of Cp. It's a ratio. Cv upon Cp is 1 minus gamma. Gamma is equal to 5 by 3, so it is 3 by 5. So write down this du is equal to 3 by 5 into dq. So according to the first law of thermodynamics, dW is equal to dq minus du. So put the value of change in internal energy. It is 3 by 5 into dq. Simplify it, we get the amount of work done is 2 by 5 of q. So for the question number 19, the correct option is 2 by 5 of q. So the option number A. Next one, question number 20. For a certain gas, the ratio of specific heat is given by, so this gamma is equal to 1.5 Cp upon Cv. Then for the gas, what is the relation between Cp and Cv? So we get this is Cp by Cv is equal to 1.5. So write down Cp is equal to 1.5 into Cv. According to the relation between this specific heat, we get put the value of this Cp is equal to 1.5 of Cv. So 0.5 of Cv is equal to R. So put the value of this. So we get Cv is equal to twice of R. This 0.5 to the right hand side, twice of R. So Cp is equal to Cv plus R means it is 3R. So we get Cp value in terms of R, and this is equal to Cp is equal to 3R. So for the question number 20, the correct option is B. So similarly, you can solve the remaining questions on this thermodynamics, that is the first law of thermodynamics, Carnot engine, as well as some questions on the Kirchhoff's law of radiation, Stefan's law is there, as well as the black body radiation. Try to solve the remaining questions. Thank you.